Decarbonization Day, what more suiting than having a conversation about one of the hard-to-abate sectors? We'll be talking about aluminum and the decarbonization of aluminum. It's, I would say, one of the building blocks of our modern society, so I think quite fitting to go a little bit into depth about how we actually handle that sector. I understand it'll grow by around 80% by 2050, so it's important. We have an amazing panel today, cross-sectoral, covering, I would say, a lot of good angles on the topic. Salman Abdullah here next to me, Executive Vice President, Environment, Health, Safety and Sustainability at Emirates Global Aluminium, EGA. We have Niels Angel, Catena X Project Lead for CO2 and Sustainability. And we have with us Miles Prosser, Secretary General of the International Aluminum Institute. And myself, my name is Simon Berkebeck. I will be moderating the session, and I am the lead of the climate and sustainability topic in BCG Middle East. So very happy to run this panel with you. To begin with, let us just run through each one of you briefly about your organization for those of you who don't know the background.
Thank you very much.
Salman.
Thank you very much, Simon. Is it working? Yeah. Thank you very much, Simon, for the opportunity. Salman Abdullah from Emirates Global Aluminium. Emirates Global Aluminium is a primary aluminium producer since 1979. It's one of the world's largest premium aluminium producers, and we have been operating for over 40 years. And EGA has its own technology for smelting purposes, which means the improvement in efficiencies and innovation is always happening. And over the years, we have reduced our specific energy, which is the energy required to produce 1 ton of aluminium. So we already have a track record on efficiency and environmental protection, and not just from today, but from the very beginning of time. We are based in 3 different countries. We have 3 different locations. In Dubai is the original smelter. Then more recently, we installed a plant in Abu Dhabi. Total capacity is over 2.5 million tons. And then we also have our refinery, and we have a mining in Guinea. So quite a big gig, but vertically integrated and producing top high purity aluminium.
Thank you, Salman.
Thank you.
And if I may add, very significant contributor to the GDP of the UAE, and I think that's important given that we're in the UAE pavilion.
Absolutely. Yeah.
Niels.
Yeah, Niels Angel. I work for BMW, which, as you probably all know, is a car company. Although we are one of the smaller car companies, we have a global footprint. We have factories in Europe, obviously, in the US, in China. Actually, we have an operation in Egypt as well. And we are making premium products, premium cars and motorcycles. And in recent years, we have found that the messaging around premium, the sustainability aspect is getting more important. We have always been, I think, on the forefront of sustainability developments in the last decades. I might say we were the first company to have an environmental officer in the car industry in Germany. But the supply chain and the product carbon footprint, the emissions of the production phase of cars has come into focus in recent years. And we're putting a lot of effort in understanding the supply chain better. I myself lead an industry-wide project BMW helped to set up to collect data over the supply chain, also environmental data, and especially product carbon footprint data. So we believe, especially if you're looking into electrification, we need to make an effort together with our suppliers. And EGA is a very important strategic supplier for us in the aluminium sector. We need to make an effort to bring down emissions in the supply chain, in the production phase of cars. And that's why I'm here today to talk about that.
Thanks, Niels. Miles.
Thanks, Simon. Yeah, Miles Prosser from the International Aluminium Institute. We're the global body for the aluminium producers around the world. And we're a genuinely global organisation. We have producers in all the major regions, Europe, North America, in the Gulf, Middle East, also producers in China, South America and Africa. So we're the forum by which those global producers come together and address a range of issues. And a lot of our work revolves around addressing sustainability issues and improving the performance of the industry. And obviously a key part of that is around emissions reductions.
Excellent. So let us get started. Miles, I'll turn to you first, right? I think given your broad overview, can you help us sort of set the stage? Why is aluminum important? What is the role in the overall decarbonization journey, and what are the key things that we need to think about?
Sure. So there's two sides to the aluminium story when it comes to climate change. The first of those is that aluminium is a solution for reducing emissions in many parts of the economy. So we're seeing aluminium assisting the transition to electric vehicles. We see aluminium used extensively in the generation of renewable energy and the transmission of that energy to customers. And we also see aluminium being used as a fully recyclable, infinitely recyclable packaging product for food and drink packaging. So aluminium will deliver emissions reductions and deliver solutions in other parts of the economy. But aluminium is also an energy intensive product to produce. And because it requires continuous firmed electricity, in many parts of the world that means that there are significant emissions associated with the production of electricity. So at the current situation, aluminium is responsible for about 1.1 billion tonnes of CO2 emissions, or about 2% of the global CO2 emissions. About 70% of that footprint is associated with the electricity supply, and the remaining 30% due to direct emissions and ancillary uses. So part of our role is to look at ways that we can reduce that footprint to something which is compatible with the global climate change targets. So our organisation looked at the trajectories and pathways that the industry could take in order to meet global targets, 1.5 degrees, beyond 2 degrees, net zero, and basically summarise those actions into three main pathways. The first of those pathways is to decarbonise the electricity supply. The second of the pathways is to implement technologies which will reduce direct emissions in the production of aluminium, inert anodes, electrification. And the third of the pathways is around recycling, increasing the already high rates of recycling and looking to improve resource efficiency. So those pathways, as we can talk a bit later on, are actually quite challenging to meet, but as an industry we are aware of the technology and the sort of trajectories we need to take in order to meet global climate change targets.
Thank you. So obviously being here at COP, we're all excited about talking about decarbonization, but I think it's also from a business perspective interesting to illuminate the why. Like, what is the opportunity here? Is there a request from customers? Is there investors that are supporting? Or why are we actually doing this beyond the global goals of net zero? Salman, what is driving EGA to reduce emissions and decarbonize?
In order to understand what drives EGA, I will draw everybody's attention to Baba Zaid's quote on the screen up there. We cherish our environment, it is our heritage, it is part of our land. This was not said after a COP. This was said in the 70s. Yeah? And every big organization, and I'm getting goosebumps as I'm speaking about it, every big organization in United Arab Emirates has that DNA built into that. Whether you look at ADNOC, you look at DIWA, you look at EGA. That DNA to keep on improving its efficiency and take as little as possible from the resources as possible is part of, is the way the life used to be before UAE became a modern country. So EGA takes inspiration from that. Now let me give you one example. In the early 2000s, there were no regulation, no requirement for us to do any work on the environmental aspects. But we converted a large fleet of our gas turbines to low NOx burners, which means the emissions to the environment to be as low in NOx emissions as possible. There was nobody asking us to do that. It had no benefit on the P&L. It made our machines more complex to operate, more difficult to maintain, but EGA would do that. We are also a technology pioneer. We have our own technology, and by constant improvement and innovation, we have been reducing of how much resources it takes. So this is the reason why EGA has been doing it, not from today, but from decades. So I know it's very topical today to talk about GHG reduction and all that, but we are one of the founding members of ASI, which is Aluminium Stewardship Initiative. People are still getting challenged of what does ESG mean. We are the ones who are sitting around with our peers, with our customers, and with NGOs in defining these KPIs, and GHG was right there up. So this is the reason we are doing it, and it just so happened that it is now a business opportunity as well. In the earlier discussion, you heard about the impact of CBAM. So even if there is no premium for the low carbon metal, we have to offset those challenges and hurdles, which could be quite significant, to overcome if you are not going down on the decarbonization pathways. You heard from Miles, this is a business with 3 steps: energy, process, and refinery, and we are way into that process, but that's our DNA, and that's why we do it.
Excellent. That's quite inspiring. I think in BCG and also personally, we see that there's opportunity in decarbonizing as well. Of course, there's a lot of different challenges, but I think for most companies, it is a significant business opportunity. So it's quite inspiring to see that there's both sort of the DNA behind it, but there's also recognition of the opportunities from a business perspective that is there. And I think that's a good segue to you, Niels, as a customer of the aluminum product, right? Maybe you can illuminate a little bit what is your decarbonization journey, and how does that then funnel up into your supplier network?
If you look at the automotive industry, we have been pressurized to bring down emissions by our customers, also by regulators in the last, I would say, decades. But it has been focused on the use phase mainly. And I think we found a solution here with going down the electrification road, building and moving towards electric mobility. And that is going to take out a lot of emissions of the uses if you use green energy up to 100%. But that puts the focus now on the production phase and the supply chain of the cars. And there's a big discussion in the media, at least in Europe, but I think in other parts of the world as well, about how much carbon electric cars, especially batteries, are emitting. And the other aspect is the cars are getting heavier because batteries are very heavy. So this is not only an efficiency question in the use phase, but also an engineering challenge. We need more lightweight materials to make battery cars, but we also need to bring down the emissions of these materials, and that brings us to aluminium. We are going to see that the aluminium content of electric cars is going up because they need to get lighter, and aluminium is the solution for that. So it's an important part of the road to electrification in the car sector. But then we need to take out the emissions in the production phase, because customers are asking us about that. And this is a discussion, and they're saying, oh, electric cars are not as clean as you make them out to be, because you're putting in a lot of energy, a lot of carbon emissions in the supply chain, in the production. And so we need an effort, and this is what we're making, to bring down the emissions in the production phase, and especially in energy-intensive materials, such as aluminium. So we need to talk about green electricity and making aluminium, about putting up recycled content. This is a big discussion as well with our customers. It's easy to understand, not use too many natural resources, not produce waste, but bring that back into the cycle. So these are the two big topics here.
So essentially there's a customer demand for electric vehicles that drives both an increased demand in aluminum, because it essentially is needed in order to bring down the weight, but then there's also a pressure on the scope 1 and scope 2, and increasingly the scope 3 emissions as well, that is then essentially causing you to say, hey, we need to work with our suppliers, we need to find a way to decarbonize aluminum, because that is what the customers in the end is looking for. Yeah. Interesting. How does that funnel through these thoughts into the overall aluminum industry? What are the targets that we're setting as a whole?
Yeah, so when we did our modelling work to develop the pathways, we took as the starting point the International Energy Agency's 1.5 degree scenario, and we combined that with our own knowledge of aluminium industry emissions. So what we developed was a pathway that was compatible with that global 1.5 degree scenario of the IEA. What that tells us is that the aluminium industry would need to reduce its emissions by 95% by 2050. So essentially reduce them to virtually zero. And the interim sort of points along that way are that the reductions would need to be about 25% by 2030 and 70% by 2035. So if you think of how that trajectory looks, that's a significant reduction to begin with, but then a very rapid reduction from 2030 to 2035. Now that's not us saying that we want a few years to wait before we get going. That's a reflection of the fact that some of the technology is not available yet, and even the technology that is available will take some years to implement and roll out across the industry. So if we look at the sort of technology that's needed, there's some of it, as I say, that's available now. So decarbonised electricity supply is available in some form or other, but there are challenges in how you supply that in a way which is firm and continuous for an aluminium smelter. Then there are other technologies which are not ready yet, but appear like they're going to be ready within the next few years. And so I'm thinking particularly around inert anode technology that would remove the carbon emissions from the consumption of the anode. It looks like that could be commercially available within the next 3 or 4 years. And there would then be the task of how you roll that out across the industry. And the final category are technologies which we think we know what the technology will be, and we have research and development. We are testing it in various places, but it hasn't yet been tested at a commercial scale. So that's the technology like electrifying the alumina refining process, or developing hydrogen as an alternative for the current use of gas and coal. So what's needed is a combination of things. One is the investment in the technology to bring it to commercial deployment, and then the very substantial amount of investment that will be needed to roll that technology out right across the industry.
We'll dive a little bit more into the technologies later on in the conversation, but I want to sort of take stock as well, sort of what is EGA doing, right? We know that we need to do something that's in the DNA. What has been the sort of response and actions beyond the ones that you mentioned so far?
Yes, so I mean, in UAE we are very privileged that the government has taken a very advanced step in installing significant amount of renewables in the country. And now the first part, as Miles mentioned, is the decarbonization of electricity. This is the most important part because it forms more than 55% of our carbon emissions. So this is where EGA is now leading and looking at decarbonization of its electricity by divesting in what we have already as captive power plant, which is gas-fired. And the other thing we need to understand that when we are looking at reduction on the electricity decarbonization, it's different for different parts of the world. So if you are in part of the world where you are relying on coal, the reduction is significant because that's really high carbon. On the gas-fired, it's medium, so it's about 55% of your emissions. But if you're already in a place where you're already using renewables, then there's no decarbonization of electricity as such. And that brings us to the next challenge. So this is what EGA is doing today, but after that, beyond 2030, the challenge becomes significant. Now let me give you an example. Miles spoke about new technologies coming by 2030, but that's already too late for a progressive organization which wants to expand now. So maybe by the time it comes, for many of the people, the boat has already sailed. So we are looking at other possibility on our smelting process, which includes carbon capture. But again, to your question, what are the challenges about it? They are significant. I've been speaking We've been speaking to a number of people who expertise in carbon capture, but our carbon capture is from the processes is different because it's not just pure CO2. It's a collection of various gases, so it's not just a collection of the gases and capturing it and utilizing it, but it's also filtering through the other gases which are mixed with the emissions. And of course, after that is a refinery, and we are hoping that green hydrogen for the consignor and moving from thermal energy into electric boiler technology is the next step for EGA. So these are on 3 pathways: decarbonization of electricity, decarbonization of the smelting process, and then the refinery.
Okay. And are you sort of working with the customers as well? Or how is that collaboration?
Yes, so we work very close with our customer and understanding their requirements and what are their targets and what are we contributing to their carbon footprint. One of the projects which is under feasibility study, and it will be the first major remelting of scrap in UAE to be used in primary metal. This not only meets the customer requirement because the customers are demanding more recycled material in our primary product, but it also reduces our carbon footprint way below than what is now deemed today as a benchmark of approximately 4 tons per ton, but it brings it below that. But we don't stop at that. There are many methodologies on how you consider scrap. Many people may consider pre-consumer scrap as having no carbon. We are taking a more stringent view that we will be looking more on the post-consumer scrap because it means the original intent of the product has been fulfilled. The carbon content has been utilized, and that is to us really a carbon-free scrap rather than the pre-consumer. So these are the steps and philosophies EG is following towards our path to net zero.
It's interesting that the sort of using of scrap and the recycling creates another problem that you essentially need to know what you're using, right, in order to be able to represent that well to the customer. Yes. And I think that's a segue to you, Nils, of course. Can you reflect on sort of what you are doing in order to reduce the need, of course, as well for aluminum, right? That would be one lever, the recycling part. But then also this tracking part. How do you know that it's low carbon?
Yeah, I myself lead a project, which is an industry-wide project, to measure the product carbon footprint and first to standardize how we report, and then to set standards how we measure and report over the value chain. Because only if you know what the product carbon footprint is really like, and that reflects also the process actually used in the supply chain, you can define measures to bring them down. So it's important that we track that and agree on a common methodology here, how to measure. But also, I found it quite interesting what you said about post-consumer scrap. We also need to collaborate on things like that with passporting and tracking our products and making them easier to recycle. At the end of their life cycle, that will be 10 years or 15 years from now, battery cars are actually very long in the market. We need to be able to access information. What is the aluminium grade in it? Where is it? How can you dismantle the car? So that we actually bring the material back into the cycle and close the cycle, let's say, in a short loop, not in a very long loop.
No. Yeah, I can imagine that sort of direct relationship between a big aluminum customer and a big aluminum producer. That step might be simple to understand the traceability, but as soon as you add in the recycling, the scrap aspect, then it becomes quite complicated, right?
Yeah. That's why I say it needs to be an industry effort. I think not one company can do that alone. And we need standardized methodology, but technology can help us here with the passporting, which keeps records over time accessible in a digital platform. So we are working on solutions for passporting our cars and actually show exactly for one car what is the content of aluminium, copper, battery materials, and how can you best recycle them so that commercial enterprises, dismantlers, can access that information and have access to information how to dismantle the cars. Because this is what is lacking nowadays.
Yeah. And so Miles mentioned that we need to go to 25% by 2030, but already 5 years after that, we need to go significantly beyond that. And that recycling was a big part of that. I would assume, what is the timeline for this? Because it seems like it's an important unlock to be able to understand whether something is low carbon or not.
Well, we're already working on, in our current product cycle, to making the car more recyclable, let's say, to mark the materials. And this digital solution will come out, let's say, next year, so very soon. So working on passporting solutions to actually come out soon. But as I said, the cars will be then in the market for quite a long time. So we will need, obviously, technology and solutions for the cars currently in the market, how to bring them back as well.
Yeah, so if you have the passporting now, then it takes maybe 10 years until the car is scrapped, and then that works. Yeah. Okay. Let's turn to the technology side again, right? I think it is striking to me that some of the technologies are not, fully ready at scale yet, and yet we of course need to decarbonize. But at the same time, the volumes are growing, right? So you have this dilemma of what do you do in the short term. Can you reflect on that? Salman had a perspective, of course, what are some of the key technologies? And I think also from a business perspective, it's interesting to hear about what are then the costs of this? Is it expensive? How much do we need to invest as a society in order to get there?
Yeah, sure. So one useful point of reference, so the Mission Possible Partnership recently released a decarbonisation strategy for the aluminium sector. And in doing that, they estimated that the level of investment required to meet these sort of targets for the sector would be $1 trillion of investment by 2050. Now that seems to me like an enormous number. I'm assured by various people on the investment side that it is achievable, but it seems to me to be a very rapid rate of investment that's required in order to both develop the technology and to roll it out across the industry. And I think in some ways that's the key challenge. I can see clearly how the technology will be developed, but ordinarily a new technology might take 2 to 3 decades to be rolled out across an industry as various facilities look to reinvest and update their plant. And we simply don't have that sort of 2 or 3 decades available to us to roll out these new technologies. So I see one of the biggest challenges as being how we actually roll out these technologies at a very rapid rate so that they go from being a demonstration plant in one place in the world to actually being implemented in all the aluminium smelters around the world. Now, some of those technologies are general and will be applicable to large parts of the economy. So decarbonised electricity is something that will be necessary for all parts of the economy. And even some of the industrial heat requirements that we have in alumina refining will be similar to other industrial processes. So it won't be a technology that's unique to aluminium. But there are places where the technology solution is a unique aluminium one, whether that's inert anode technology for reducing emissions in the smelting side of things, or development of alloys and recycling sorting technology in order to be able to recycle aluminium to its highest and best use. So there's a range of technologies there that need to be developed. The pathway to get there seems clear, and I have confidence that we will be there within the next few years for many of these technologies. But it's that investment challenge of how you roll that out across the globe that'll be one of the key determinants as whether we as an industry can meet the sort of targets we're talking about.
And how is that being handled then? 1 trillion, it sounds, here at COP, right, you hear trillions being mentioned quite often, but for one specific industry, it seems enormous to me.
It does, and I think we're off to a really good start. So one of the things we've seen, if we break it down to both a commitment and an action side of things, so on the commitment side of things, we've seen 1/3 of our members sign up to the Mission Possible Partnership within a few months of it starting. We've got 70% of our members that have explicit greenhouse gas reduction targets, and 80% have targets, 70% have net zero by 2050 already as their target. So at the commitment level, it's off to a great start. On the investment side, we're seeing investment in all the major technologies occurring already, and we're seeing that investment occur in all the major regions around the world. So in terms of getting global action and getting action on the technologies, it's all starting well. But again, that challenge will be how can we scale that up to the sort of numbers that we're talking about and how can we expand it out both geographically and along the value chain to make sure that we can meet all these targets that are there.
And Salman, maybe you can reflect on this topic as well. How are you managing this uncertainty about technologies, the huge need for investment and yet the higher demand, right? You lock yourself into some plants if you expand, but then you still need to, of course, reduce the emissions from them. What are the trade-offs
Yeah,
there?
so I mean, when we are expanding, what we are looking at is other technologies like carbon capture. It is more challenging to carbon capture from the smelting process than it is to carbon capture, let's say, from a power station. But this is, we have, as I said, we are a technology-driven organization. We have been hearing about these different inert anode technologies coming for over 10 years. And, you know, it's a bit tiring. So we are, as a technology innovator, we are partnering with other peers and looking at carbon capturing and seeing how that can help reduce our carbon footprint. At the same time, we are constantly reducing the specific energy of our own product. So we have a number of new projects in which the existing content, the carbon-based anode technology, in which the specific energy is reduced. But we are looking at decarbonization from other aspects as well. We are looking at circular economy. So some of the material which comes out as a byproduct from our industry is now becoming a feedstock for other industries, like, for example, for cement. SPL, or spent pot lining, is a byproduct which comes out, and it actually reduces the nitrate oxides and CO2 from the cement factories. And this is not something, just because it's our product, I'm blabbering about it. We had a team from MIT to come in and write a paper on it, and they did, for 6 months, study this process, how it goes to other industries and reduces their emissions of up to 0.75%. So cement is another hard to abate, so we are assisting them as well. So we are not in the going to wait till somebody comes up and say, here is a product. But if I can also challenge the industry that even if you come up with it, there's 50, 60 million tons of existing technology operational today. It's not retrofittable. So it's only when you make a new plant that this new technology can be done. So we are looking at technologies which could be retrofitted, not just in the future plans, but on the existing plans. So that's the direction we are taking. I think we are done with the waiting game.
Yes, indeed. The implementation COP,
Yeah.
right? So done with the waiting game. I like that. I think it's interesting this way to sort of future-proof your current investments, right? Because you know where you need to go to,
Yeah.
and even if the technologies are not ready, you know you need to implement them at some point, right? So preparing for that, it seems like the right way to go. I'd be curious to hear as well on this, how do we get there, right? Because when I hear the different perspectives, right, it seems to me that this is so big that it's not something that any individual actor can do.
Absolutely.
Right? I mean, you need to collaborate with maybe power sector, you know, to decarbonize the power. There's customers, of course. There's the huge needs for investments. And then there's the big R&D topic as well that we talked about. How do you see this collaboration and the sort of stakeholder management part of the puzzle to get there?
I mean, it's the core point. I mean, the industry itself cannot do these type of investments. I mean, we talked about the $1 trillion, but a lot of that has already been spent. I mean, if you look at, if we are importing power in an aluminium industry from a nuclear or from the solar parks which have already been installed, so you already can say that investment is now mapped to the aluminium industry. So it's not that we are starting from zero. There are a lot of investments have been done, but we have to make the correct connections. There's a lot of renewable available in other countries which have smelters, but they have not made those connections. We in the UAE are lucky to leverage those investments into aluminium industry. So a lot of that $1 trillion, I think, is already can be mapped into the aluminum industry. But it's key that the policies around it, the regulators and different regions recognize this and not become a hurdle in industry moving towards decarbonization. You can make any kind of policy which sounds excellent maybe 10 years ago, but we need to, or the regulators and the industry needs to together look into it, that this is already a hard to abate industry and it's a fundamental industry for the future. You know, aluminium is so essential. It's lightweight, it's recyclable, infinitely recyclable, and you have to remove hurdles from its way to move its journey towards zero emissions. So it's extremely important. This collaboration and policymakers have to really take note. And if some things have been decided 5, 10, 15 years ago, we need to re-look at it together.
Okay. Any comments to this? Otherwise, we're unfortunately running. Yeah, Nils.
I think that was a very, very interesting, very good point that we also need to invest in innovation, innovative technology. So there's technology which is there, but we also need actors to push for innovation, because that might give us the bit we don't cover nowadays. And I think we need collaboration from our side as well to develop the supply chain together and help companies to be innovative and bring new technology on board to bring the emissions down.
Yeah. I think, so we're running up against the clock. I would just ask each of you to sort of reflect on the conversation, right? But I think from my side, it's striking that aluminum is a really big contributor to our daily life, right? It's super important. It will grow tremendously over the next years because we all want to use it. But it is a really big emitter, so it needs to be handled. It is not easy. That's why we call it the hard to abate sector. There's parts of it, right, that is basically the technology is not ready. So we can do a lot on existing parts, right? There's a lot of efficiency, a lot of recycling, the power sector connection that you mentioned, but there's still a lot of stuff that essentially needs to mature in order to get there, right? And that's why I would think that the 25% is in 2030, and then it goes down, right? Hopefully the technologies will mature with the collaboration that is required. To close out, I just ask each one of you to sort of general reflections and final statements. Miles, maybe you go first.
Sure. I think it was good that we had that final question there around collaboration, because I think that is the key to making the sort of advances that we need to make. We're seeing a number of companies making very significant investments to reduce their carbon footprint, and I think Salman's company at EGA is leading the way on a lot of those things, really reducing the carbon footprint by making substantial and significant investments in changing electricity supply. But the challenge will be in working on those collaborative issues, whether it's product design, recycling of alloys, and we've identified the right partners in the conversation. Investors, customers, and governments are a key one. I think we shouldn't overlook governments, because one of the critical issues here will be ensuring that the companies, the actors that make the first moves, are actually rewarded for having made those first moves, and there does become a commercial incentive to make these investments and implement these technologies.
Interesting. Nils?
Yeah, aluminium is getting and will be more important for the car industry and for many other industries, I think, as well in the next few years. Carbon emissions need to come down substantially. The way forward is green electricity, investment in good processes and bringing up recycling, and also innovation. And the customers asking for that. And I think we have to go down that road.
The customers are asking for it. Nice.
Yeah.
Salman?
Yeah, I mean, I'll take a slightly different take on this. I think the supply chain of the aluminium industry is one of the most complex. You have very big players and small players. And EGA recently signed up to First Movers Coalition. And why this is so important, because from our suppliers, there are many, many small suppliers, and you heard from even the previous panel that not everybody can bring it to the table. And even for us to produce our low carbon metal, it's significantly more challenging. It's significantly more expensive. So our customer needs to understand that that this is more difficult and there has to be a premium for that. Likewise, for our suppliers who supply ingredients to our industry, if they can come up with low carbon products, because that helps us reduce our final product's carbon footprint, then we are, as part of the First Movers Coalition, looking at supporting that, to put the money where the mouth is.
I think that is a very encouraging note to stop on, right? Customers are demanding it, but that then leads to action, of course. But what that also does is that you can help your suppliers actually drive down their emissions, right? So there's really this cascading effect. Even though it's difficult, there are pathways for this very important but hard to abate sector. So I'd like to thank you, Salman, Niels, Miles. Thank you very much for the contributions today, and thanks to the audience. And enjoy the rest of your stay at COP.
Thank you.
Thank you, Simon.
Thank you.